Welcome, everyone. This is the last session of the conference. You guys are troopers. Thank you for coming. I'm gonna try to make it worth every minute that you're here on coming in and trying to impart the most knowledge I can so it's worth the stay, right? So, name's Freddy. I run the Java Pub House, which is a Java learning podcast. I also run Java of Heap, which is essentially Java News. Being honored to be a Java champion. I help co-organize the Seattle Java Users Group, and I'm part of Expedia Group, right? And what all this really means is being around the block and made a lot of mistakes. So what I want to do is kind of share that a little bit with all of you so that hopefully you learn from my mistakes, right? So for those who don't know, Expedia is what is like an online travel agency. If you go to expedia.com, you can just search for hotels, you can search for cars. I work on what is called the flight stack. So every time you do a search for I want to go from London to Chicago, you're going through code that I wrote, or, well, me and my team wrote, right? So one of the things that happened, and one of the things that we're going to cover here is that this is essentially you can think of this is a haystack trace, if you know haystack, but what it is essentially a time slice of where are we spending time on the different microservices. You can think about it like each one of these lines is a microservice. We actually calling these in parallel, but the important part is like the big line at the top is what is considered the full response. Like that is essentially the time when you put the search from I want to go from Seattle to Chicago, from London to New York. That is when that line is done, that's when we display the results. Now, the interesting part is that the meaty part of the search, the part that takes technically the most time, this is when we go get an inventory and stuff, is actually only 4 seconds, but the full search takes around 9 seconds, right? So when we started actually going deep into this and trying to figure out, this is kind of weird. Right, we're looking first at our deployments, looking at our containers. Are we right-sizing it? Are we memory starved? Are we CPU starved? Right, and we're like, yeah, that seems okay. So that was the first 5 days. The second week, we started cracking our heads and trying to see okay, what is it? It's not Java. It's not garbage collections. Why are we actually spending time? And by the third week, we kind of gave up. Right, So the fun story is, even though I'm painting you a dire picture, the great story is that after what we apply on this talk, this is sort of like our new stack, right? This is the top bar is still the amount of time that we actually take doing this stuff. The second bar there, where the second arrow is actually the quote-unquote the meaty stuff that does most of the search. So we figure out this is a redemption arc. We figure out what was wrong. We figure out where did we go, in our architecture, where did we do a left turn? And a lot of it had to do with the not so subtle cost of microservices. So what we're gonna go over is the overt and hidden cost of microservices. That's the first part. The second is the right reasons to microservice. There are actually very good reasons when you decide I'm gonna create a microservice. But we're also going to go about the wrong reasons to microservice, right? It's sometimes something that we don't think about. We just think it's all right, I have a new thing that I need to do. Let's start with a new microservice. But after this talk, I hope that you get a little bit of a pause and say do we really need to? And if the answer is yes, because of these good reasons, then great, do it. But if the answer is maybe there's a better way, then follow your instinct and say maybe we shouldn't do a microservice. And we're gonna show you if you don't have to do a microservice, what do you do instead, right? So I like to think about it this is Superman versus Batman. Like Superman is the guy you always go to because he's a friendly guy who is right there to help, and that's how I'm like thinking. Like people think about microservices. He's gonna help me out, and he's always gonna do it. But after this, I want you to think it is more like Batman, where it's like he rules by fear. He will help you, but you don't want to call for him like to be at your kid's party, like, right? So overt and hidden costs, right? The known knowns, these are the things that will just almost like automatically comes into mind when you're creating a microservice. It's like, yeah, you know what? There's going to be hosting. This microservice needs to run. It's code that actually needs to run on a CPU somewhere. There's network costs, right? Like you need to actually have bandwidth. You need to make sure you have a good backplane, or that the cloud infrastructure you're managing, that you're provisioning, you're making sure it has a good backplane. And and there's the operational cost, right? Like if you're doing like a Spinnaker deployment, or you maintain that infrastructure, or you have a GitHub account, that's a new repo you have to maintain, all these things, right? So those are very transparent and it's essentially the known knowns, right? But every time you create a microservice, they are definitely costs that you're paying, and these are not necessarily monetary costs. The first one is this concept of complecting. By show of hands, who knows either of this book or what complecting means? Okay, so this is going to be a fun opportunity. Right. So what complecting means is to interweave, right? And the way that this kind of looks like is, have you ever have like one microservice, two microservices, you add a third microservice, and suddenly you need to coordinate these changes on the 3 services before you can deploy or do anything? That's what happens with complecting. If you happen to cut your service in a weird or wrong way, then now instead of having one problem isolated over here, you have one problem that now is distributed in 3. And now, the best part is like, I'm just going to show you. This is Satire by the Kraken team, but they explain it much better than I can. So we're going to watch a 3-minute clip of what happened to them. This is Satire, by the way.
I'm still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we?
Can you guys hear it fine? All right, let's see. Let's see if I can raise the volume a little bit. Okay, so that's at 100%. I'm going to try to raise it a little bit more. Oop. Ah, there it is. Oh, juice. See? And why did it decide to just return to a different volume? All right, there we go. Sorry.
I'm still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we get this done before? Look, I'm sorry. We've been over this. It's the design of our back end. For example, Bingo service. See, Bingo knows everyone's name out, so we get the user's ID out of there. Then for Bingo, we can call Papaya and MBS to get that user ID and turn it into a user session token. We can validate those with OldMount, and then once we have that, we can finally pull the user's info down. Yeah, look who's the raccoon team, basically. No, raccoon isn't guaranteed to have that info. Before we do this, we have to go to the command, do a query to see if the user's willing to take it to the next level. There's claims of field. Now, Wingman is cool, but he doesn't store any user info himself. He has to reach out to other user info provider services, like RGS, Barbie.com, Ringo2, BLS. But how does it know what all the user provider services are? Well, for that, it has to go to Galactic. All know the user service provider has. Well, Galactus has omniscient knowledge of all current user info providers. It doesn't have future sight or knowledge of past user info providers, so it expects a time. To get all current user info providers, we need to pass a time range with current time and a time representing the end of the universe. We get from EKS, our entry chaos service. We deprecated at the end of the month for Omega Star, but Omega Star still doesn't support ISO timestamps like they said they would a month ago, so until Omega Star gets blocked. We can't use that for our use case, but we can't use EKS. There's nothing we can do. So Galactus won't be able to find our new birthday boy provider, which means Wingman won't know how to talk to anybody, which means I won't be able you sad, pathetic little product manager. You think you know what our users want? You know nothing of my pain, of Galactus's pain. You think you know what it takes to tell the user it's their birthday? You know nothing. Delivering this feature goes against everything I know to be right and true, and I will sooner lay you into this barren earth than entertain your folly for a moment longer. Alright, so clearly this is a blocker. No problem, we'll push this out another 2 to 3 years or so. Learned a lot today. But we'll talk next week about adding middle names to the profile. Awesome, sounds good. Take care.
By show of hands, who identifies? That was me, like crying at the end of every meeting, right? But like, and it's kind of it's fun, but we can see that happen, right? Like if you are at your job, you can see that when a new microservice was introduced, suddenly there was like 2 things that you have to worry about instead of 1 thing. So that is, and it's what they call it, like boiling frog problem, where, oh, what is one more microservice, right? And then suddenly you add, what is another microservice? And when you realize, then you do get architectures like this. Like it was a little exaggerated, but there are things like that out there, right? And the problem that you have is that by in itself, it's what it is. But like if you have a bug, it means that you have to suddenly trace through all these services, and that is something that happens even today, right? Like you go in, you start on the UI. There's let's say there's a flight that is showing up when they shouldn't, or something that shouldn't show up is showing up, and we said, was it the UI? Oh no, was it the UI? Okay, fine. Was it the GraphQL layer? No, it wasn't a GraphQL layer. Was it essentially a translator from the supply to the GraphQL layer? No, that wasn't it. You go then, was it the pricing service? Was it the baggage service? Was it, and you have like, it gets to be like at least a day of trying to follow through until you find which one. Once you find it, the bug is usually 10 lines to fix. But to get there, the more systems you have, the more time you're going to spend just trying to figure out what went wrong, right? And same as same on the side of the feature. Sometimes adding a feature, if you have multiple services and the concerns are not split correctly, it means that you have to add, quote unquote, that feature, or like that, let's say that you need to add that birthday field, or like, whatever flag. You have to add it into 4 or 5 repositories. You have to expose it on 3 different services so they can get the setters, or get the date, return the date, show the flag, all that stuff. So they become things that used to be very simple to do when you only have 2 or 3 systems, become extremely complex to do because of complecting once you have 10 or 15 systems. The second hidden cost that we tend to forget is uptime. So this is a math problem. Let's see. If I have a service 1 that has 99% uptime, and I have a service 2 that depends on service 1 at 99% uptime, what is the uptime of this system? What was it? 98%. Right. The uptime formula to know how long your system is up is essentially uptime of service 1 times uptime of service 2 times uptime of service n that are part of your critical path. So 99% times 99%, you get an uptime of 98%. Guess what happens when you have 3 services? Right? Your uptime now becomes 97%. Now remember when we were all like finding out about 9 nines and 6 sigma and all that great stuff? If you try to introduce Six Sigma and you create a microservice and you have to have that uptime, your target is not 99. Your target is going to be 99.999. And by that time, then you are doing very crazy stuff. Like you have US East, US West. You have like AWS plus Google Cloud because US West 2 can go down. Like it might not make sense to try to put all these things to guarantee that uptime that you SLO, right? And one of the things that happened with us is that in a private structure, essentially, and this is sort of like a very simplified thing of how our service work, where we have sort of like the flight offer service, the flight product service, the air pricing service that prices the different flights. And we have a baggage service, which is trying to figure out, oh, it's going to cost you $30 to bring a bag or carry on or a check-in bag, right? If this thing went down, everything went down. And so in that sense, sometimes they say like microservices allow you to be like more resilient. It depends. If the microservice becomes fundamental for the operation or to be able to answer those responses, it means that now because they are complected, that one error in a small part of the system is just going to make the rest of the system fall over, right? So one of the questions that come in is like, but Freddy, I mean, like, even if we didn't have this many services, the code is still the same. The code has to do the same thing, right? And the answer is more subtle than that. What happens is that a lot of the downtime is not necessarily related to code that you wrote, but also, for example, your deployment pipeline. Like, something happened when you were trying to deploy. You have a very overeager service that at startup, will connect to the database and try to download all the records. And suddenly, on your auto scaling, you first started at 500 instances and then tried to go down. And then your database was flooded because all these things were spinning up, trying to get to the database, trying to get all the information. And suddenly, that service went down, right? And until we know this as therapy, because that's what happened. We actually had a service that its purpose was, as a startup, is like, we're going to cache all this flight information. We're going to go to this particular DynamoDB database and get the stuff. And of course, AWS is very good at saying, I'm going to throttle you because you told me not to charge you $1 billion. So suddenly, all these services were starting up. They were essentially being behind. They didn't pass a health check because they were still waiting for Dynamo to return. And then you got into this sort of like you start flapping on these services, right? So these kind of complexities are like the things that you don't think when you're creating when we are putting a new microservice. And these are the things that you kind of like have to know that you're paying the prices. Like, if I'm putting a microservice, I now have to be aware of not just that I need to create code that is not complected, but I need to figure out how to make it such that it keeps the uptime. And that usually means things like, I need to be aware of how am I deploying it. I need to be aware of what kind of like ramifications have it if I have to like replace my version, right? This is essentially Peter Dush fallacies of distributed computing. And we sometimes, as developers, we kind of know they exist, but sometimes we just kind of like not look at them too hard. In this particular case, the one of the main reasons that we run into concerns and issues of latency was essentially these 4 parts. Like the network, we thought the network is reliable, latency is 0, infinite bandwidth, and transport cost is 0. And all of this happened because the airline industry loves to work on XML. Now, yeah, we should be fine. So if you ever work on XML, right, like the payloads are essentially, the grammar is great. Bruker Borges will like say XML is the best thing in the world, which, yeah, there is some of it, right? But the thing is, like, for us, what it meant is that, we have these XML documents. We needed to essentially encode them, write it on the wire, decode them. And that took both time. It took 1 second to do these operations because our essentially our flight offers, when you have sort of like a round trip flight or a flight that can have 2 or 3 stops, could go upwards of 60,000 possible offers, right? And expressing that on XML, encoding it, decoding it, and transmitting it over the wire, not just that it took 1 second to do because there were 1 megabyte payloads, but it actually make our CPU work at 100% while encoding and decoding, right? So these were like the systems that we used to have, where all these arrows are essentially that 1 megabyte XML payload either going in or going out of the systems. So if you think about it, you're doing this 1, 2, 3, 4, 5, 6 times across your architecture. That adds up, right? So that's where we learned the hard lesson that transport cost is not zero and the bandwidth is not infinite. It's not instant getting from one place to the other, right? In retrospect, that was obvious, but we did have a good story around it. Now, so like the first, I'm gonna ask a couple of questions to the crowd. For those who are in Expedia, you probably already know, so don't break the curve. We're gonna work with this. We're gonna work together on this. So, by show of hands, who have worked with XML? All right, we all suffered, don't we? All right, so if I were to tell you, like, all right, oh, XML is very textual, very big. For those who are like if you only grew on the XML world, what will be your response? It's like, oh, instead of XML, we should use. Okay, so what did I? Okay, so YAML, which is, and I hear Jason over there. You broke the curve. All right. So the idea was like, actually, did anybody said fast info set? See, like you just dabble in XML. You're not hardcore, die-hard XML fans. So fast info set was the binary representation of XML with sort of like a little dictionary on top, right? So that was like, again, these were like flight systems that were done, like the flight industry is still in the 60s. We managed to move them to the 90s with the XML and fast info set. When we actually created some of these stuff, JSON was not a thing. But there was like a fast info set, which is binary XML. After that, somebody else came in and say like, no, this is too verbose, and Bruno Borges, so I keep rapping on him, has not gone into the Twitter scene yet, so everybody thought that XML was horrible, that we should use JSON, right? And some people went to JSON, and then they said like, but it's still very big on in the protocol payload, because JSON is still like a textual, it's still a textual protocol, and if you don't want to use JSON because it's text, what will you use? So the binary representation of JSON is named BSON. So it's essentially a way for you to, like, if you're working with JSON and you actually are concerned about like payload size and stuff like that, BSON could be a very easy way to like do it, because essentially you take the JSON, there's a binary serialization on it, and it runs. Don't do it if you don't need to, but if there's pressures, then that might be an easy way to go in. And I'm borrowing this from Gil Tenne, who like is from Azul. He always said, like, the internet works as if it has the debug flag on. And what he was trying to say was that we tend to send a lot of text for machines to process. And if you think about it, that doesn't make any sense, right? Like, machines do not care what protocol you send it on. The machines actually work best in binary, right? So the best protocol, and that's where it came in, is there is the ability to do, like, and this was a study by Google. Google actually had this, like, again, they were the first one to suffer through these kinds of problems. So, or at least the ones that decided to open source their stuff, they come up with protobufs. Protobufs is essentially binary messaging protocol / standard, where you define essentially your message, how is it going to look, and service A and service B have essentially the message definition, and then they can be very, very succinct on the wire. Like, the guys are really trying to shave bits out of it. So if you really are hurting, and once you start measuring, if you say like, oh my gosh, I'm spending all this time encoding, decoding, and serializing, and you have to do the thing, protobufs is a good solution. There are others like Cryo and other ones like out there. Proto is kind of like the not trusted one, but it was the first one. It was, you can then lay out gRPC, which is remote procedure calls using protobufs. And it works well. Like, usually from protobufs to cryo, maybe there's some gains sometimes, but maybe it's not worth it. And like at least observe, if you have a place to start there, right? Having said that, though, the fastest way to optimize something, what is it? Does anybody have any ideas or suggestions?
Don't write it.
Is to not do it, right? We have all these microservices that need to talk to each other, right? What about if they're non-microservices, they are just part of the same code base, where we don't need to actually create a message to send over the wire because there's no wire that needs to be sent. It's just a method call on the same code base, right? So that is, and there's a story that we're gonna go into, like what we did, but the thing that I want to put in the seed in is like that is one of the things that you do pay on microservices. That is like you do have to communicate again to other places, right? And that means that you have to do an encoding and decoding and work on the network. So if you just realize that is a cost that you're paying, maybe it's worth not doing it and just put it inside your system. Now, the right way to do microservices, the good reasons, like the ones that I see that these ones make sense, we should do that. The first one is asymmetric scaling. What that means is that you have an actual like service is doing all these things, and suddenly you add something new to the service. You add a new module to the service, and suddenly this module, you realize you're profiling it, is burning the CPU. It's making your service, like, instead of going from one instance to, before you needed 5 instances to run in your stack, now suddenly you need like 20, 50, or 80 instances because the machine learning service is essentially occupying most of the scaling, right? So that it makes sense to say, okay, you know what, this is a very specialized part. There is a good reason to scale differently asymmetrically, meaning like I want to still have my 5 services on the top, but now the machine learning one, then I can scale up and down, and I can optimize by saying like, for this scaling, I want to use like CPU heavy machines because that's what they need to crush. Like those are very, very good reasons to say like, okay, let's split it so that we can control the scaling and we can make sure that this particular kind of operations have the right hardware behind it, right? The second one is mix of tech. As much as we all love to going into greenfield and startup, the reality is that 99% of the code is about maintainability, right? Like the code that we find we're actually maintaining. So if you have like code bases that have like mix of tech, it perfectly makes sense to essentially encapsulate these as microservices and let them talk to each other, right? The third one is divide and conquer. Now, the funny story about this picture is that I was just looking for general statue picture on Google, and I picked the first one here. But if you look closely, if you have watched Shrek the movie, he looks like Lord Farquaad. So there's a statue out there in the world where there's a statue of Lord Farquaad from Shrek. But there is there is the argument of divide and conquer. Like not all microservices are bad. Like it's not that I'm telling you shouldn't do microservices, but like it does allow you the ability to essentially say I'm going to make a deployment here without affecting anything here because this is a service that has its own pipeline and I can just deploy whenever I can, right? And that usually works with the caveat if the thing is correctly sliced. Meaning, if you didn't complex the systems, if you didn't make these systems so codependent that you cannot deploy this without deploying that, right? Now, the last part is that I wanted to go over is the wrong reasons to microservice, and this is the ones that I personally made a mistake on, and they are very, very easy to make. Now, we software developers or engineers sometimes we say we are not very, very creative. But every time they say to me like, oh, we need to go to that code base, I'll be like, oh, we should do a microservice because of ABC. We need to use Java 17. All this, like, I can come up with 200 different ways that I can say, no, we should really do a microservice. And the reason is because every time I open an old code base of people that already left the company, that's me. I'm like looking it through like, oh my gosh, what am I gonna look at, right? But that is not the right approach, right? Like books like the Pragmatic Programmer, said you gotta do the People Scout rule, where you go to the park, you do your little fire, but when you not just you put out your own fire, but you're supposed to clean up a little bit more of what you did, right? And that is sort of the attitude that we have to go every time we have to touch an old code base that is not up to snuff, is to like not just do our part and get out, but is do our part and start cleaning up a little. And if everybody starts getting a culture of doing that, code bases do get cleaned up. Like code bases do get better, but it is something that requires like purpose, and it needs to be deliberate, right? Like Pragmatic Programmer has that. There's some patterns that you can do. There's like the strangler pattern, where you try to essentially move code a little bit within the code base from an old place to a new place, and you're essentially first putting some BDD or TDD, and then sort of like saying, okay, we're replacing this class with this class now because it has that logic. So there are ways to do it, and that's way preferable that you say, nope, I'm not even gonna touch that, I'm just gonna create another service. Because now you definitely created like if these two are competing code bases, they're a competing concern, or like they're the same concern, they're just like you didn't want to touch it, you definitely complected, right? How many times my juniors have told me this? I want to do this project and it will be perfect. I will use Java 17. I would use Loom. I would use all these things. I'm gonna use the latest and greatest thing, and it's gonna be like the best thing since sliced bread. And that's when I'm old enough to know that they are good intentions, and they have to start that way. But we know that that's not going to be the case. A lot of the times, what's gonna happen is it was great when it was done in 2020. By 2025, it's like, oh my gosh, we're 5 versions behind. We now need to go in and upgrade Log4j 3, and you gotta like just go and reinvest in it. So even though it's very alluring to say I want to start anew because I don't like what I saw, is not like you really have to sit down and saying it's greenfield and that it's gonna be perfect is not good enough. You can make a case, and there has been cases where a code base got so gnarled and it got so much tech debt that it's like, okay, yeah, it's gonna take us the same amount of time to create something new than to try to refactor it. Fair, but if that's not the case, then just saying it, I'm gonna do something great from the beginning is not worth it. The fourth part is having a micro that's too micro. The problem, and I hate that word microservice, is that nobody quite understands what is the definition of micro, right? So and you do get things like bingo, where there's a service that just tells you what other service you need to consult. Like oh, because it's single principal, right? Like it's, yes, but the single the responsibility can be a little big. It doesn't have to be, I'm just gonna do additions, and if you want subtractions, you go to the subtraction service, right? And so we have all this, right? We have the search service, we have the orchestrator service, we have the rules service, we have the offer service, we have the pricing service, right? And then I'm looking at it, and you know what? This service just does one thing. It searches for flights. And that's what we came with, flight search service, and that is the scope, right? So, the idea is like, what to do. Like, let's say that you have a situation where you're like, okay, to microservice or to no microservice. Well, what is the solution then? If you're telling me, Freddy's telling me I shouldn't do microservice, what you want to do is we tend to forget that computer science started way before and microservices was not a thing. And this is, like, for those who have been on the industry long enough, they know what this is. This is essentially a modular monolith, where you actually create very clear boundaries on like where your code is, and we now have languages that supports many different ways of enforcing that boundary. It does require discipline. One of the appeals of the microservices is that the boundary is by definition in there, and that is very attractive. But if you're disciplined enough, then you can actually have a larger code base that is not split in 10 microservices that you can still maintain because you enforce these standards. You don't need to have what is called a ball of mud, right? Like that is what you used to call like just something that has static methods everywhere and you call everything. No, right? Like you do want to do what is it like loose cohesion and tight coupling. The advantage you get is you don't have the need for encode, decode, and transfer. Everything is there. All the logic is there, so you can reason about the things. It's like the flight is not coming up. It's one place you look and one trace you have to look at to try to figure out what happened. So, and that is essentially what we did. We essentially took 4 of our services that were microservices, right? And we decided, no, we are going to essentially collapse these out. The SRS is a service that essentially have rules for us to evaluate. So their payloads and the communication with that was very light. It wasn't the big XML payloads. The paths are essentially our connectors to the industry, and they have to be separated because every carrier connector is different because that's how people like to do business. So we needed to make sure that we didn't like commingle that code. But we got all these in, and for the parts that we couldn't, that we have like a service we have to communicate out, we actually said, let's use protobufs to actually, optimize for bandwidth and CPU, right? And my last parting words, and then I can open it up for questions, is that as engineers, as software developers, as architects, like the thing that we have to remember is that there is always a trade-off. Nothing comes for free. And as long as you can like if something seems like it's too good to be true, like, oh my gosh, I'm gonna use this library, it's gonna fix it all. There is a trade-off down there, right? Like even when you're choosing garbage collectors, some of them do have incremental benefits, right? But even then, it's like, okay, what is is G1GC better than Shenandoah or these other ones? And it's like, and they do have profiles. Like a lot of the experts says you have to profile your stuff before choosing one over the other. Right, because they are like, one of them is better at managing big pools of memory. The other one is more of a generational, smaller object creation. So these, as long as we keep that in mind, and we just don't say, let's just do microservices, but go with the eyes open that a microservice means that I'm trading these things off, then we're fine. And that's what makes us better engineers in our job. And last part is Expedia Group is the one who sent me here. They kindly pay for my plane ticket. Well, I hope they do. And hotel. So yes, PSA, we're hiring. If you're interested, great company to work with. You can come work with me. Let's fix microservices together. So yeah, if you're interested, let me know, and I can try to point you to like the places that we actually have careers and stuff like that. So that's it. So questions? At least two questions. This is not ask me. No. I'm demanding 2 questions from the audience. All right.
Like you said, like finding the issues in microservices is quite difficult, but how about fixing the bug and deployment after like finding it?
Correct, right. So the question is all right, if you find a like if you have a bug and you have a system and it's like 10 services and suddenly only this service over here is the one that has the issue, right? Like and you fix that, and it becomes very easy to just like, okay, well, theoretically it becomes very easy to just say, I'm just going to deploy this, right? That is true. That is actually a benefit of the microservices. If you do have a modular monolith, unless you're very, very disciplined on, for example, just doing like continuous integration, continuous delivery, you will stumble a little, right? Because I fixed something here, I fixed something there. There's multiple people working on the code base, and if you're not deploying constantly, then it becomes a chore, right? Like, because it's like, okay, we gotta figure out A, B. How many commits were coming in? Did we took too long, and now we have to wait for a while before releasing? Yeah, so that one is a trade-off. Yay for microservices only if they're split right. Because if you fix the bug here, but that requires you to deploy everything, then you didn't gain anything there, right? All right, at least one more question. Yes?
So what's a microservice?
If you don't know, that's great. It's like, you are ahead of the game. That's Billy, by the way. Yeah, he definitely knows. So, like, he's my competition in podcasts and Twitter. So. I have. Oh, okay, and that's Anna Maria, who sounds amazing at doing the test containers and stuff. But yeah. All right. So, do I have another real question?
With the microservices, I think we have people trying to use different databases. Does it bring the challenges also? Like one microservice has different database, another different database. It is designed for, but then sometimes doesn't it duplicates the data also?
Okay, so you're saying, what if there's two microservices that talk to two different data sources?
Yeah, but then sometimes you have to pass the information or also store the information in other microservices also for validation purpose or keeping that same information for
Correct.
duplicating the data, which is
Right. So when we talk about having a single concern, and that we split the microservices the wrong way, if suddenly you have two microservices that is writing and essentially the data is incomplete until the two parts are together, or like something puts them together, then that is a strong signal that what it needs to have happen is that one microservice should have take care of these two data sources or these buckets of information instead of being split between two of them, right? Because that is essentially that should have been your concern. My concern is I'm taking care of this data store as part of my concern, so you don't have to split that over to and there are patterns. There is like sometimes it is legitimate that two services do need to consult or update the same data or different data sources, but there are CQRM. That was one of the patterns. Like Marcus Eisel talks a lot about it, where there is a way to essentially do more of a transaction log. That, we need to do these things, we need to update this, we need to delete these things. And then there's a third part of it where it just picks it up. It's like, okay, I can get a consistent view of the data because there's a messaging that these two services are publishing down that says, update this, delete this, and a third one that consolidates them. It's CQRS, I think, is a pattern. But yeah, if you really need to split it, the easiest way, have them in one service. All right, we got to 2 questions at least. Does anybody has more questions? Yes?
What differences or similarities do you see between like an API versus a microservice?
It's almost, gosh, we're gonna get philosophical here. It's like Plato. It's like okay, and actually I'm gonna use this because it actually works, and I will never get to say that I didn't do this. So Plato, the philosopher, has this concept of ideas, and he says like, a chair doesn't exist, only on the mind. The perfect idea of a chair doesn't exist in the real world, it's just in your head. And there's approximations of chairs. There's things that almost look like a chair but might not be a chair, but that happens in the real world. So, APIs are the perfect expression of some kind of contract that you have. Microservice implementation is all the craft that come from actually taking it to the real world, right? An actual microservice needs to have a deployment pipeline, a code base, a technology stack, all these things that make it a microservice. Technically, if a microservice is correct, it will implement and honor the API, which is a contract that you created. But, and that's where it sort of kind of deviates, where some microservices implement, for example, the REST API, right? It's a very well-defined standard. Most people don't do it the right way, just because it's hard and we're lazy. All right? Other questions? And I use Plato on one of my talks. It's way worth it. All right. Any other questions?
What's the right strategy to do the end-to-end testing between the API and the microservices that we have?
Contract testing?
That is the best.
That's another talk. But it is, what you're talking about is contract testing. There are tools. I think a lot of it is more process. Like, for example, there are certain things that will force you in a contract. Like the way out, for example, gRPC. Say, like, I'm defining the messaging, I'm defining the methods, and then if somebody implements the gRPC endpoint, they need to honor that, and that kind of comes for free because you just have to. Now, then the comes is like, is the contract, well, is the call or the remote procedure call doing what it's supposed to be doing? Then you get into the integration testing side of things, where there's tools for that, where you try to say, I put this as a gRPC call, I expect this response, something bad happened, and then you can integrate tests on that. Other questions? Yeah.
So with NoSQL in the C, so there's more of like denormalization happening, like so that we can get all the data in one call, and that on one side, and with microservices where we intend to have like a separate database for each of those microservices on its own, so that's more of like splitting the tables into like normalizing it. So where do we draw the line? Like what is the best practice?
I'm crying. The reason I'm crying is because I know a world before NoSQL. So it was called SQL. And what a lot of people like everything else, right? Like I said, if there was one thing that I want everybody to get out of this, that there is trade-offs, and there's a good one that you said, that denormalization, right? Denormalization, what does it get you? Denormalization gets you the ability to kind of like scale horizontally, because you're essentially breaking the information in ways that are like, that starts getting duplicates. Essentially, when you denormalize, you're duplicating data, right? But then for example, this NoSQL databases thing allows you to scale horizontally, because then you shard by key, and suddenly you can do 1 billion records. If you don't need that type of scale, then NoSQL is not necessarily the best tool. A lot of people say it's like, oh my gosh, I need 10 million records. We need to go, big data, auto scale, and it's like, MySQL can run 10 milliseconds like nobody's business on my local machine. Like that, we tend to forget that these technologies, like SQL technologies, are fine. So for example, if you don't have the big data, and if you don't have the if you don't have the performance requirements where like a SQL server, a SQL cluster can scale fine, and it will start breaking around. I think it's like 500 million records is when it starts to like eke a little bit. Then my answer to that is like, you can probably try to survive with one source of truth. I'll worry about the auto scaling once you actually can prove that is an issue. That is, I know like the way I usually take a look at it, and it's kind of funny because we have juniors, right? And then there's the seniors, and then seniors is like, oh, I'm gonna do this, and I'm gonna try to design forever. And then you get the principal like me, which is the dumb one, and says like, no, I'm just designing for the next 3 months. I like that. That's my window, right? Like, oh, but we may have 20 million customers coming this way, and like, then we'll figure it out then. And essentially, I designed for 3 months with the license to refactor, which means that I know I probably made a mistake. I know what the conditions are going to change, but I will deal with that then, right? And then you can do the measurements. It's like, look, we're having a bottleneck on here. Okay, now we do need Mongo, we need Dynamo, or whatever it is, because I can see it. But until then, just don't worry about the scale until it hurts. And that's usually the best way to create code that actually caters to that instead of something that runs $5,000 on your AWS bill, but you never actually need it. All right. Any other questions? All right. Thank you so much. My name is Freddy.